Today we're going to learn how we solve basic equations where the unknown is present on both sides of the equation. So let's begin. I want to start with considering the following problem. What if I've got 3x plus 2 and all of that is equal to 2x plus 5? Well, remember, equations are like balancing beams. Both sides of the equation should balance. So I've represented that in a set of scales in front of me, where on the left hand side I've got 3 of those x's and 3 of those dots because I've added 3 onto it. And on the right hand side I've got 2 of those x's and I've added 5 of those green dots. And right now that set of scales balances. Now you might be wondering visually, how would I work out how many of those green dots are in each one of those little x boxes? Now to do that, I need to isolate just one of those x's on one side of the equation. It doesn't matter which side, but because I've got more on the left hand side than the right hand side, I'm going to isolate it on the left hand side. So on the right hand side, I need to remove those 2 x's. Now I could just take them away, take them off the scale, but obviously that would uneven or unbalance the scale. So I would need to repeat that on the left hand side by taking these 2 x's away here. So what I've done here is I've subtracted 2 of these x's on the right hand side and subtracted 2 of these x's on the left hand side. And what I'm left with on the left hand side is 1 of those x's plus 3 of those green dots. And on the right hand side I'm left with just 5 of those green dots. So this still balances, and I've found that x plus 3 is equal to 5. But I still haven't isolated x on its own on one side. I've still got the plus 3. So I need to perform the inverse of that. I need to take away these 3 green dots. But whatever I do to one side of the scales to keep it balanced, I must do on the other side of the scales. So I'm going to take 3 of those dots away here. So I'm subtracting 3 from the left hand side, but whatever I do to one side, I do to the other. So I subtract 3 to the right hand side. Now on the left hand side here, these two will cancel each other out, and I've isolated the x on its own. On the right hand side I've got 5 subtract 3, which is equal to 2. So I'm proposing that there's 2 of those green dots in each one of those x values. But let's think about what I did algebraically there. The first thing I did was I needed to get all those x values isolated to one side of the equation. To do that, I looked at which side of the equation did I have more of those x values. You don't have to, but that's what I chose to do. So I decided to remove the x values away from the other side of the equation. In this case, I decided to remove them from the right hand side, and to remove them, because I was adding 2x there, I need to subtract 2x. But of course, to keep it balanced, I have to do the same thing to both sides. Now, when I subtract 2x to the right hand side, these cancel, and on the right hand side, I'm left with just the plus 5. And then on the left hand side, I've got 3 of these x's, and I'm taking 2 of them away. So I've only got 1 of these x's remaining. Of course, I've still got my plus 3, so x plus 3 is equal to 5. From here, I do what I did in the last video. I need to isolate the x by looking at what would be the last thing I would do on that left hand side. Now the last thing I'd do is plus 3. So to get rid of that, I need to perform the inverse, which is to subtract 3 from this side. But whatever you do to one side, you must do to the other. So I subtract 3 from the right hand side as well. On the left hand side here, these two values cancel, and I'm left with the x. On the right hand side here, we've got 5 subtract 3, which is equal to 2. Therefore, our x value is equal to 2. But of course, with all these sorts of problems, we can check to see if we're correct. So let's perform a check step by using substitution. So we repeat the equation, but wherever we see an x, we substitute the 2. So on the left hand side, we've got 3 multiplied by our 2 plus our 3, and that should equal 2 multiplied by our 2 plus our 5. Now on the left hand side, 3 times 2 is 6 plus our 3, and that should equal to 2 times 2, which is 4, plus our 5. 6 plus 3 is equal to 9. 4 plus 5 is equal to 9. They both equal each other, so therefore it's balanced, and we've found the correct solution, where x is equal to 2. So as you can see, we just follow a set of steps here. We first get the x's isolated to one side of the equation. Then we isolate that x on that side of the equation to work out what that x should equal. Let's try that again with a new problem here. I want you to consider the problem here of 8x plus 4, which is all equal to 3x subtract 21. Pause the video now for a moment to have a go at it yourself before I run through the problem. How'd you go? Well, let's have a look. The first thing that I would do here is to isolate the x's to one side of the equation. Now, because I've got more x's on the left-hand side than the right-hand side, I'm going to remove the 3x from the right-hand side. Now, the 3x on the right-hand side is a plus 3x. To remove it, I need to subtract 3x from this side. But whatever I do to one side of the equation, I must do to the other, so I must subtract the 3x from the left-hand side as well. Now, on the right-hand side, these will cancel with each other. And what I'm left with is that subtract 21, or the negative 21. On the left-hand side, I've got 8 x's, and I'm subtracting 3 of them away. So I'm left with 5x, but I'm still adding the 4, and that equals negative 21. From here, I need to isolate the x on its own. To do that, I work out what I would normally do on the left-hand side. So I'd normally go 5 times x first, then I would add the 4. So the first thing I have to remove is the plus 4. And I do that by performing the inverse of addition, which is subtraction, and I subtract 4 from this side, which will cancel it out. But whatever I do to one side of the equation, I must do to the other. So I must subtract 4 from the right-hand side of the equation. On the left-hand side of the equation, I've got 5x remaining. On the right-hand side of the equation, I've got negative 21 subtract 4. The answer is becoming more negative. So, negative 21 subtract 4 is negative 25. Therefore, 5x is equal to negative 25. What does 1x equal? To find that out, I must perform the inverse of multiplication because it's 5 times x. Now, the inverse of multiplication is division. So we divide by our 5 and this will cancel. And on the left-hand side, we're remaining with just the x value. And that's going to be equal to negative 25 divided by 5 to keep things balanced. Negative 25 divided by 5 is equal to negative 5. Therefore, our x value we're proposing is equal to negative 5. But of course, we can check our solution to make sure that we're right by using substitution. So if we substitute the x value of negative 5 into the equation, we'll have 8 multiplied by negative 5 plus 4, which is equal to 3 multiplied by negative 5 subtract 21. Now 8 times negative 5 is negative 40, plus our 4 should be equal to 3 times our negative 5, which is negative 15, subtract our 21. Now negative 40 plus 4 is going to be negative 36, and that should be equal to negative 15 subtract 21, which is negative 36. And because both sides equal each other, we've found the correct solution. And that solution is x is equal to negative 5. So the key steps to solving an equation where the unknown's on both sides. The first thing we need to do is get just the unknown on one side. Then we solve the equation by performing our normal inverse operations. So now it's your turn. I'd like for you to solve each of the following by finding the value of the pronumeral.